Okay, for this second part of the video on electrical safety, we'll be focusing on double insulation and then go on to explain why switches, fuses and circuit breakers are to be fitted to the live wire. Okay, so let's go to double insulation. So some of the appliances actually do not need earth wire. Okay. Example, for those with a 2-pin plug, they are usually having the appliances made the outer covering to be made from plastic, okay, non-metal. So whenever we have this kind of appliances that uses outer covering made of plastic, we do not actually need a 3-pin plug. That means there is no need for earth wire. We still need live, and live is actually 240 volts, which is a dangerous high voltage. We also need the neutral, which is at 0 volts. Okay, just to recap, live wire is brown in color, neutral will be blue in color. Alright, so we only need the live and neutral wire. That is why in a socket, the top part is the plug for earth, then we have live here, and we have neutral. Okay, but since it is made of plastic for these appliances, there is no need for earth. So we just plug in these 2 pins. Okay, so plastic insulation actually provides 2 levels of insulation. Electric cables are insulated from the internal components, and the internal components are insulated from the external casing. Maybe I do a drawing for my what you call that, a hair dryer. So basically there's a heating element inside, and maybe this is placed in a plastic housing. Okay, so the heater, and also there might be a fan, right, to blow out the air. It is enclosed in a plastic housing. Okay, and the handle that you hold onto is also made of plastic, and there is no metal to be seen or in contact with your body. So in this case, being plastic, it is an insulator of electricity. There will not be any chances whereby you get electric shock. Okay, unless of course you tell me the live and the neutral wire, there are some exposed, there's some wear and tear, and results in copper wires being exposed. Then in that case, there could be chances of electric shock. But if everything goes well, we are holding it by the plastic handle, okay, and the appliances are housed within another plastic housing, that is like double insulation. So in this case, there won't be any need. Even if there's a fault, we are holding on to the plastic, there won't be any electricity or electric current passing through the human beings. And the symbol for double insulation is this. Okay, 1 layer of plastic followed by another layer of plastic. Alright, you can actually find this double insulation symbol on the appliances itself. Okay, so that is double insulation. Now we go on to the last part, which is why switches, fuses and circuit breakers are to be fitted to the live wire. So I say again, live wire is 240 volts. It is very dangerous. Switches are actually designed to break or complete an electrical circuit. They should be fitted to the live wire. Okay, now we take a look. This is live. Okay, and in this case, the switch is actually fixed to the neutral wire. Yes, it is not at the live wire part. So current flows as you can see. Okay, it flows, and let's say there's an electrical fault. This is an electrical fault. Okay, and the metal casing becomes live, right? So even though so when this happens, right, and something is wrong with these appliances, maybe it's not working, we first of all, we will turn off the switch, right? but this switch is being located at the neutral side. Neutral side is 0 volt. However, you see that the appliances is still physically connected to the live wire. It's still physically connected to the live wire. And when there's an electrical fault, something is wrong with the appliances. So somebody touches it, and since the switch is in the wrong position, right, the person touching it will make the connection to ground, and there's a potential difference. Current will flow through the person. Okay, even though no current will be flowing through the appliances when the switch is open, but physically, I say this is important, physically the appliances is still connected to the live terminal. Okay, so this is dangerous. What happens if the switch is connected to the live wire? So this is again our live wire, dangerous. Now there's an electrical fault. The heater is no longer working. So we go on to investigate. But before we investigate, we turn off the switch. The switch now is open. Right? We need to off the switch. And the switch now being located in the live wire, it actually physically cuts off the appliances from the dangerous live terminal. Right? So now we can just take this heater out. With no physical connection to live, everything is safe. So this is important. The switch on the live wire disconnects the metal casing from live wire when the switch is open. How does this apply to the fuse? Imagine now, before we turn off this switch, there's an electrical fault. Let's say over here, there's an electrical fault, right? Current flows, it touches metal casing, and this current actually exceeds the fuse rating. Right, because there's a surge in current, the fuse will melt, and now the fuse being located in the live wire, it forms a physical barrier. The open circuit is in the live wire itself. It helps to disconnect the appliances from the live wire due to this gap. Okay, that is why your the fuse, your circuit breaker, and your switches should all be connected to live. Okay, should all be connected to live. But when the question is posed to you, why should fuse, circuit breaker, and switches be connected to live? A lot of you will say that when electrical fault happens, okay, an open circuit will be formed. Right? So let's say I either open the switch, circuit breaker trips, or the fuse melt, and open circuit will be formed. No current will flow, which is true. So far all of this is true. But if this doesn't happen, if all of these are not connected to live, right, you are missing out this point that if fuse, circuit breaker, or switch is connected wrongly in neutral wire, okay, this will still happen. Okay, but if the fuse, circuit breaker, or switch is connected wrongly in the neutral, appliances will still be physically connected to the dangerous live terminal. Okay, because you set all this safety to be in neutral, but the break happens in the neutral wire. It didn't happen in the live wire. Therefore, the appliances will still be physically connected to the dangerous live terminal. And this is all due to electrical fault, meaning there is something wrong with the appliances. You still have it connected to your dangerous live voltage. Your life will be in danger. Therefore, fuse, circuit breaker, or switch must be connected to live so that we can disconnect the appliances from the dangerous live terminal. Alright, so you have to try all these practice questions. Okay, after you have tried, I will actually upload the answer, or I'll do another video to go through it. Okay, and if you have watched all these videos, it is time to try your tutorial. So because we don't have much time left, I will need you all to try your tutorial, and then I'll upload the answers and maybe do another video for this. Alright.